Hi class, it's me, Mr. Morris. This is the second part of the stoichiometry review. In this video, we're going to be focusing on limiting reactant, excess reactant, how to determine if it's a limiting reactant problem or if it's just a standard, what did we call it, basic stoichiometry problem like we did in the last video. How to tell whether it's a limiting reactant problem or not. Okay, so limiting reactant, excess reactant, how to tell whether it's a limiting reactant problem or not. Determining the amount of excess that is left, that's kind of a difficult type of problem. And then we're going to talk about theoretical yield, actual yield, and percent yield, how those topics come into play. Okay, first of all, how do we tell if we have a limiting reactant problem? Well, a basic stoichiometry problem has only one amount of reactant given. So they're just going to talk about one reactant. And if that's the case, you're going to do the same type of problem we did in the last video. Same process. If we have a limiting reactant stoichiometry problem, you're going to have two or more of the reactants given. You're going to have the amounts for two or more reactants given. And if that's the case, you just add one step to the problem than what you would do otherwise. Okay, so let's start out by talking about how to solve these. First of all, you need to make sure the chemical equation's balanced like we did before. Things that you need to remember here. Remember, it's got to be balanced. The top numbers are the moles of the given and asked parts of the problem. We already talked about that. The bottom numbers are moles according to the coefficients of the balanced equation. Again, just like in the previous video. But this part's different. We just want to find the ratio of the top and bottom number of all of the reactants. We're not actually setting up a proportion. We're just going to divide. You just do the moles from the problem divided by the moles of the reaction and find out what the answer is. That's the first step. We want to do that with each reactant given. That's going to tell you the number of batches of reaction you can get. It doesn't tell you the answer to the problem, but it tells you how many batches can we make, or how many moles of reaction. That's the word that we use in AP chemistry for batches, or how many times the reaction could occur, whether it's 4 times or 12 times or whatever. And you're going to find that for each given reactant. The substance, the reactant, that gives you the lowest ratio is the limiting reactant. We're going to do some practice in just a minute, so don't worry. After you've done that, you're going to use the limiting reactant to solve the problem and find how much product is produced. That's how you determine the amount of product. So this part is just like we did in the previous video. The only difference is we use the limiting reactant, and we're going to kind of set the excess reactant aside and ignore it for a little bit. To determine the amount of excess reactant that's left after the reaction, this is what we have to do. We're going to use the limiting reactant ratio to determine the amount of excess reactant used in the reaction. In other words, the excess reactant becomes the new X. So it's what we're looking for now. So once you determine which one's a limiting reactant, which one's the excess reactant, you can find out how much excess is used by doing the limiting reactant ratio and set it equal to X over the coefficient of the excess reactant. We will do examples in just a minute. After you've solved that, you take the moles of the excess. If you want to find the moles of excess reactant that's left after the reaction, you would do moles of excess before minus the moles of excess that was used in the reaction. So we're going to do what we started with minus what we found right up here in this previous step. Again, examples are coming in just a moment. Last thing that we're going to talk about in this video is theoretical yield, actual yield, and percent yield. Sometimes I want to know the percent yield of a problem. Keep in mind, all these calculations we're doing, they're theoretical because we haven't conducted it in the lab. We're just solving problems, and that's what theoretically on paper, that's the way it ought to work. But the actual yield is what's done in the lab. So read what's on the paper. That's basically what we just said. Theoretical yield is the amount of product produced based on the stoichiometric calculation. It's what we're predicting based on our calculations. The actual yield is the amount of product produced in the experiment, so when you actually do it in the lab. And if we want to find the percent yield, we always do actual divided by theoretical times 100. And that's your formula. Okay, let's wrap this up. We're going to do example problem on this page, and then we got one more page of examples after this. Starting out, it tells us what we have. We have 15.00 grams of aluminum sulfide. And I have 10.00 grams of water. And they're reacting until the limiting reactant is used up. This, for some reason, printed as a box. Draw an arrow. It's supposed to be an arrow here. That's our yield sign. All right, the question first. Part A says, what's the limiting reagent? What's the limiting reagent or limiting reactant? Well, before we can get started, we really need to do our steps of a chemical or of a stoichiometric calculation. Step 1, find moles. I have grams of two different things. I got to find moles. So we're going to start with step 1 here. All right, I've got 15.00 grams of aluminum sulfide, Al2S3. I want to find how many moles that is, so I'm going to start by putting my molar mass on the bottom, which happens to be 150. And you could calculate that, 150.14 grams of Al2S3. If you were to crunch the numbers on that, you're going to get 0.09991, and that is moles of Al2S3. All right, that was our first reactant. Let's do the same thing with the second reactant on the other side of this line. So that was 15 grams of aluminum sulfide. Let's find it with 10.00 grams of water, which is, of course, H2O. You may have the molar mass of water memorized. If not, I know you could find it. 18.016 about grams of H2O in 1 mole of H2O. So when you put that in a calculator, you should get 0.5551 moles of H2O. Okay, so there's our first step. Our second step is the balanced chemical equation, which I already have up here. Third step is to do the stoichiometry using the top numbers and bottom numbers. But in a limiting reactant problem, I've got two different moles. So there's kind of two parts to step 3 here. Starting out, I need to do my ratio. So 0.09991 moles of Al2S3 over, let's see, 1 mole of Al2S3 equals, well, it's just going to be the same number because I'm dividing by 1. But you still should write it out, especially if you're doing this problem on an AP exam. You would be required to write it out. And by the way, I just started making a mistake because I was talking at the same time. These units cancel, so we really should not write moles here unless we're going to write moles of reaction. It would be acceptable to put moles of reaction there, but you don't want to put moles of Al2S3. Sometimes that's a mistake students will make, and I almost made that mistake myself. Okay, let's go ahead and on the other side do the same thing for water, starting with this number, 0.5551 moles of H2O over 6 moles of H2O and you should get something like 0.09252. And you could put moles of reaction, but I would just leave it blank. The units cancel out. All right. Now we got to decide which one is the limiting reactant and which one is the excess reactant. So look at the numbers. Which one is smaller? This is the smaller number, so that means this one's not actually possible. You may as well cross that number out. Okay. This is the limiting reactant. H2O is limiting. And then Al2S3 is excess. One of the questions I was asked for is which of them is the limiting reactant? Just figured that out. H2O is the limiting reactant. I did part A. Part B, what's the maximum mass of H2S which can be formed from the limiting reagents? Well, that's kind of the second part of 3. Remember, step 3 is to calculate how many moles of product you can get. So I want to know how many moles of H2S I could make from this. I've got to use the limiting reactant to figure that out. So I'm going to set it up. 0.551 moles of H2O. I'm going to draw a line here because I don't want any confusion about what's happening. 0.551 moles of H2O over 6 moles of H2O equals, and I'm looking for maximum mass of H2S, so X moles of H2S over 3 moles of H2S all right. So if I wanted to solve for X, I'm going to put 0.551 times 3 divided by 6. Put that in your calculator, you're going to get something like 0.2776. And that is moles of H2S. Moles of H2S. All right, but I didn't want to know how many moles of H2S it is. Part B asks me for how many grams. It asks for the mass of H2S, so that's how many grams of H2S that we could get. So I'm going to do that up here. Part 4 is 0.2776 moles of H2S, and we're multiplying by the molar mass, which is 34. You can figure that out from the periodic table. It's 34.076 grams of H2S over 1 mole H2S. And then you should get something like 9.459 grams of H2S. All right, we just answered part B. Now we want to do part C. Part C asks us for something else. And it's kind of a repeat of step 3, or at least part of step 3. it asks us how much excess reagent remains after the reaction is complete. All right, so if I wanted to solve that, I still need to use my limiting reactant, but the excess is the new X. So basically, my excess reagent, we said it's Al2S3, so I want to find out X moles of Al2S3, because that's my excess reagent, right? This is what I'm looking for. Now I want to find the difference between how much I had available, which is up here, and how much is used, which is what X is going to be. So don't forget, we're going to find how much is left, how much remains. That's 2 steps that we learned on the previous page. We'll go through this a little at a time, but we're going to redo step 3, but this time X is Al2S3. So we have 0.5551 moles of H2O over 6 moles of H2O equals X moles of Al2S3 and again, looking at your equation, it's just 1 mole of Al2S3 on the bottom. Solve for X. X equals this divided by this, which if you do that in a calculator, you're going to get 0.09252 moles of Al2S3. That's moles. And I didn't really specify, I just said amount, how much excess reagent remains. If you want to do fewer calculations, we may as well just subtract the moles. So let's do that. How many moles did I start with? Moles of Al2SO3. We're going to make this our last step. I started with this many moles of Al2SO3, right? So I'm going to say 0.09991 moles of Al2SO3, or S3, minus the moles that I used, 0.09252 moles of Al2S3. Do that in the calculator, you get sorry, I don't have that one right in front of me. 0.00739 moles of Al2S3. But what do these 3 different numbers represent? Well, the first one represented what was available. That's what I started with. The second one represents what was used. And this represents what is left over. So this is my answer. And we just answered part C. Just answered part C by subtracting what I started with minus what I used to get what's left over. That's a little more complicated and in-depth of a process to think through, So we may need to talk about that a little bit more, and that's okay. If you have questions, please let me know. The part with excess reactant, part C, is the hardest part on this page, in my opinion. And then we get down to this. When the reaction is performed, the mass of H2S collected is this, 8.56 grams. Calculate the percent yield. This is not hard. It's pretty straightforward. You just got to make sure you keep your vocab straight. Percent yield equals, we're going to do actual over theoretical times 100. So then we're going to solve that down here. Actual is what is collected. It's what I got in the lab, so I'm going to put 8.56 grams of H2S compared to what I thought I would get. So theoretical yield's what I thought I would get. How much H2S did we think we were going to get? That was right here, 9.459. grams of H2S. Just make sure that you're looking at the same product. H2S, H2S. That's why labeling units is so important. Then we multiply by 100. Put that in a calculator. You're going to get 90.5%, which is an excellent percent yield, actually. All right. That is it for this video. I'm going to see if I can do one more example problem, the third page, and as a separate video. It is very similar. The only difference is in this one, you've got, it's a limiting reactant problem involving molarity. So if you want to go through that example on your own and then check the answer, that's fine, or you can watch the next video and I'll walk you through it.